Hi everybody, Patrick here from Engineering Shock Electronics, engineeringshock.com. This is the Epoch Learning Center, Project 12 with a 7-segment display. In the upper left-hand corner we have a 4-digit 7-segment display hooked up to chip A, and I'm actually going to remove the connections. We're going to connect them from scratch, but I want to talk a little bit about the 7-segment display. In this video, we'll only be working with the rightmost display, but in the next video we've got our most complicated project yet, and that is multiplexing all 4 7 segments. We're going to create a countdown timer that counts down 1 second at a time. And in the future, we'll be making fun. We'll make like a movie bomb prop, if you will. But much down the road, we still have to cover so many of these electronic blocks. If you haven't already, check out the Kickstarter. It's linked below, and check out some of the other Epoch videos and the code samples at the project page throughout that can be found in the Kickstarter. Okay, so first things first. 7-segment display. It has 7 segments and a dot segment. Each one of those is an individual LED. So we've got top, middle, bottom, upper right, upper left, lower right, lower left, and of course the dot on every single one. And we've got 1 pin to activate channel 1, 1 pin to activate channel 2, 1 pin to activate channel 3, and 1 pin to activate channel 4. Now the segments are labeled A, B, C, D, E, F, G, and dot. In the code, the pins on the chip that control these segments are labeled pin A, pin B, all the way to pin dot. And so how this works is, this is a common anode 7-segment display, and by that it means that each LED segment is constantly tied to 5 volts. And then through a protective current limiting resistor, the negative of the LED is tied to a GPIO pin, which, when pulled low, activates the LED segment. Now, to break that down more simply, I'm going to use the breadboard and an LED circuit to explain it using this power rail. This is the program running. It's just counting from 0 through 9, and in a loop. And that's because we're constantly changing the logic on these GPIO pins that are connected to the control segments A through G and dot. Dot is never used, as you can see, is the lower dot in the lower right hand corner, and is never turned on. So let's see how this is actually working on a more practical level. I've got a breadboard. I've got the power rail. As you can see on the upper left of the power rail, we've got 3 3.3 volt pins. We're not going to use those here. We've got 3 5 volt pins, and we've got 6 ground pins on the right. So here's the actual circuit itself. We've got 5 volts constantly connected to each segment through a current limiting resistor, 470 ohm resistor, and that protects the LED from being damaged. If you don't have a protective resistor, then there's nothing preventing current from overflowing through the LED and destroying it. If I connect this LED to directly between 5 volts and ground, it's bye-bye LED. The LED will be dead before it even turns on. So the LED itself is just a standard LED. Imagine this is one of the segments. There's a long pin and a short pin. The long pin is positive, and the short pin is negative. The long pin is called the anode. The short pin is called the cathode. So, if we reverse this, we connect 5 volts to the cathode, the negative, we'll never get our LED to work. So we have to connect positive 5 volts to our anode, which is the long pin, and our short pin we're going to connect to the right here. And we're just going to bend the LED down so you can see a little bit. So now I've got the cathode, the negative, connected to this flying wire. Now let's imagine that this is connected to a GPIO pin that's constantly changing. If I set that GPIO pin high, like digital right, GPIO high, sets it to 5 volts, nothing happens. For 2 reasons. One, there's no path to ground, so there's no circuit being made. But as well, this is the negative. You know, we can't power this backwards, even if this line was connected to ground. We have to power it in the proper direction. So if I say GPIO pin, digital right, GPIO pin low, and connect this to ground, we have a lit LED. So that's a lit segment. Now when we set a GPIO pin high, it provides 5 volts to the line. But when we set a GPIO pin, when we write a GPIO pin low, it actually not only shows 0 volts on the line, it actually provides a path to ground through the chip. So that's what's happening through here. We're constantly changing the states of the LED, and any lit segment is connected to, or is set to low, ground, 0 volts. So now let's set this up. In the next video, we're going to multiplex 4 of these. We'll create a a bomb timer in the future, a fun movie-themed countdown timer prop. But in the next video, we'll just be doing a 5-minute countdown timer. We'll play with some of the code so that we can make a fast countdown timer. I'll show you how multiplexing really works. And multiplexing has its... I'll just save that for another video because it's a whole thing on its own. But right now, I'm going to disconnect all these wires, and I'm going to connect them again for you. So the rail right below the 4-segment, 7-segment display, as you can see from the right to left, it's A, B, C, D, E, F, G, dot, DT, and then channels 4, 3, 2, and 1. Channel 1 is the rightmost segment, 2, second from the right, 3, third from the right, and channel 4 is the leftmost segment. We're going to use channel 1. You can use whatever channel you want, but I'm going to use channel 1 in my hookup here. So this is the control. When we connect 5 volts to any one of these channels, that channel becomes activated. So I'm going to connect, the code says that we need to connect GPIO pins on chip A, 2 to A, 3 to B, 4 to C, 5 to D, 6 to E, 7 to F, 8 to G, 9 to DT, and 10 to 1. So I'm going to make those connections, and again, that is on chip A. We are not using chip B yet. So GPIO pin 2 is actually right here, and they are labeled on the board. It's just a little hard to see. So GPIO pin 2, 3, 4, 5, 6, 7, 8, and 9, and 10. So look on the board for the designators and hook them up, and then you can power this up, load the code, and it should work just like you see in just a second. As you can see, I've tied the wires off using a cable tie to the left, twist tie rather, and it's counting. It's just counting. That's all it's doing. Read the commenting in the code. It's available to anybody until the Kickstarter ends. The project page has all the code, and I'll be updating that every couple of days with new projects. And yeah, so this is a very simple project. The next one, multiplexing, a bit more complicated, but again, we're going to learn little by little. We're going to cover all the bricks. We're going to cover so many topics. We're going to hit on everything on this board, and once we're done hitting on every last electronic block, we're going to start really making some more complicated, fun projects. But you have to follow along because every project is basically requires the last project and the project before that. They build on each other. So check out the code, check out the project videos. If you haven't already, you can subscribe to the YouTube channel if you're interested, but no pressure. But please do check out the Kickstarter link below. This is the Arduino Epoch Learning Center, and this is again Patrick. Thank you for watching. I hope you have a wonderful day.